Today we're going to be finishing section 4.3, looking at the properties of logs. I call this day 2 because on day 1, if you remember, we looked at the properties that will allow us to expand a log expression into a multiple log expression. Today we're going to be using those same properties to condense. Condense means go from big down to small. So we're going to be working with the same properties. These are the same properties, I just flip-flopped them for you. Because today we're going to be starting with an addition or subtraction problem where the logs have the same base, and we're going to have to determine what does it mean when those two logs of the same base are connected by a plus, a minus, and what happens when our coefficient is something other than 1. So we're going to be working backwards or condensing down to a 1 log expression where we're going to have products, quotients, and exponents in that expression. Okay. Keeping in mind that anytime we had a fractional exponent, that meant it started as a root. Remember, this would be the nth root of a to the m. So we're going to have to work completely backwards. Anytime we have a fraction as an exponent, we're going to have to convert it also back to its proper root. So let's look at some examples. These are the same instructions from my math lab. Condense each log expression. Make sure your coefficient is 1 and evaluate without a calculator if possible. So this first example, we have the common log. Remember, there's no base there, so we assume it's a base 10. And these two base 10 logs are connected by a plus. So that means we're going to condense those two common logs into 1, and the expressions in them separately are now going to become a product, which means we have the common log of 100. This is the condensed form, but the common log of 100 equals 2 because base 10 to the second power does equal 100. So we have a condensed form of the log, and then we have an evaluation of that log down to 2. Second one here, we've got 2 log base 3s. Those 2 log base 3s are connected by subtraction. The quotient rule says subtraction leads back to division. So we're going to condense the 2 log base 3s. The first expression will become my numerator, and the second expression will become my denominator. Now, because there's variables in there, we're not ever going to be able to evaluate it. However, if this expression simplifies, meaning if I could factor this expression, if I could take something out that would cancel with x, you would need to do that. This one, however, we cannot do that. Number 3, this is the first one where our natural logs or our logarithm expressions separately have coefficients that are not 1. So we have to deal with that first. So we know if there's a coefficient, we're going to use the power rule. So that coefficient of 2 is going to come back up and become an exponent to x, as well as that coefficient of 1/3 is going to come back up and become an exponent as well. Now we can condense the plus, so natural log of x squared times x plus 5 to the 1/3 power. But then we need to make sure that we simplify that root. We can't leave our answer that has a fraction exponent in it. So I'm going to change that x plus 5 to the 1/3 power into the 3rd root of x plus 5. So we have the natural log of x squared times the cube root of x plus 5. This next one, there's multiple ways that you can do this. A lot of you are probably looking at this and saying, well, I could distribute that to get rid of the parentheses. And although that is one way that you could do this, that's actually the more difficult way. So I'm going to teach you the simpler way, the way that has less steps to it. So if you remember all the way back in elementary school, you learned the order of operations, and the order of operations says if there is something inside parentheses that you can do, you always have to do that first. So I'm going to concentrate on my natural logs inside of these parentheses before I worry about this coefficient, okay? Because inside that parenthesis, the expression a and 2b, because those are in logarithms that are being added, are multiplying. A times 2b. So we're condensing the natural logs into 1, and that addition says those expressions can multiply. So we have 1/6 natural log of a times 2b is the expression 2ab. So since I condensed this inside, now that is showing me that the entire logarithm expression has a coefficient of 1/6. So now we can take that 1/6 and take it up to an exponent. And then because that exponent is a fraction, we're going to have to change it into its equivalent root. 1/6 means the 6th root of 2ab. If you go the distributive property method, you will eventually get to that. There's just a lot more, especially exponent rules in the simplifying of the expression before we could get to this. Okay, so anytime you've got something in parentheses, please make sure you concentrate on that first. Okay, this second one, I'm going to pay attention and highlight the fact that there is a minus minus here. Okay, that would mean this divided by this divided by that. We know that we can't have x, y, and z. This is not a valid mathematical expression. So what does this mean? I'm going to go back to day 1 notes and highlight this answer here. Minus, minus. When our answer ended with 2 subtractions, that meant there was a product on the bottom. And if you remember, when there's a product on the bottom, we had these parentheses we had to insert to show that we were dividing by a product, and then we distributed that subtraction to get to this. So the last thing we did here was distribute that negative. Anytime you have a negative negative, before you do anything, you're going to have to take out those negatives. So we're going to take that out. We're going to factor out that -1. When we factor something out, we leave what's behind it in parentheses. That will then mean there's a plus 10 log base b of y there. And I'm closing that parenthesis, you just can't see it. Now I'm showing that this log expression is dividing by a product, and then I can simplify using my property rules. So this 1/4 is going to become x to the 1/4 power. Subtract, parenthesis, log base b of 5 squared, plus log base b of y to the 10th. So all I did in that step was apply the power rule to make my coefficients become 1. Now I can simplify further. Log base b of x to the 1/4 is the same thing as the 4th root of x, minus, I'm now going to condense what's in parentheses, just like I did up here. So this is going to become log base b of 5 squared, which is 25, y to the 10th. So I use the product rule there. Lastly, I have this subtraction to deal with, and that means I'm going to turn these expressions into a quotient. So I have 1 log base b of the 4th root of x divided by the product 25y to the 10th. Okay, if we were in class, I would have you do this problem on your own, but since we're not, I'm going to show you how to do this one as well. Okay, so again, we've got grouping symbols here, so I'm going to worry about what's on inside here first. So I'm going to leave that 1/6 on the outside. I've got this negative negative to deal with. We know when there's a negative negative, I have to factor out the -1. So I'm going to take that out, which will leave me with log of x plus 3 log of y. The inside still has some work to do. So I'm going to have the common log of x squared plus 1. I can't do anything with that. Minus, I'm going to condense this plus problem into a product. So I'm going to condense it into 1 common log of x. This 3 becomes y cubed. Now I can worry about this subtraction. That's going to become common log of x squared plus 1 on the top, divided by the product xy cubed. And since this now condensed log expression has a coefficient of 1/6, that means this entire quotient has an exponent of 1/6. which then means that entire quotient will be under the 6th root. That is your final answer there. Okay, I gave you a lot of different examples there. In your homework, you'll be able to go back and forth between the examples. I gave you all the components that you're going to need. The final thing we're going to do today is look at what we call the change of base property. Now, up to this point, the only logarithms we've been able to evaluate are ones like this, log base 5 of 25. We're able to say that that logarithm equals 2 because we know the base 5 to the exponent 2 does equal the answer of 25. But what happens when, say, we would have something like log base 5 of 26? What does that log equal? 5 to no power gives me 26, so I can't find that value without a calculator. You can find the value of any logarithm by using a change of base. It doesn't matter whether you go through common log or natural log. You will get the same exact answers. Okay, but here is the base 10 property. It says if you have a log base b of m and you can't evaluate that on your own, you can find its value by taking the common log of our answer m and dividing it by the common log of our base. Same exponent, you can do the same thing going through natural logs. As long as you stick with a common base, either common logs or natural logs, it doesn't matter which one you use. Okay, so down here I'm asking you to find the value of log base 7 of 2,506. So I'm trying to figure out 7 to what power gives us this value. It's not a whole number, so we're going to need a calculator. So if we go through the common log, we're going to use the common log of 2,506 and divide that by the common log of our base 7. If we go through the natural log, it looks the same way. We just have to make sure we use that. In your calculator, anytime you hit the LOG key or the LN key, it's going to automatically put a parenthesis in there for you. So you're going to have to put parentheses around those. And then divide, hit the common log button again, put parenthesis there, and hit enter. You should get 4.02199. I want to round to 4 decimals. The 4th decimal is here. So that 9 tells that to become a 10. We have to carry that 1 to here. So this is going to become 4.0220. Okay, that 9 makes this become a 10, which makes that become a 2. If you do the same thing with natural log, it's going to give you the exact same answer because it is the exact same logarithm we're looking at. So now you can evaluate any logarithm, whether it's a whole number or a decimal, without using your brain. You can use it with a calculator. Okay. Hopefully this was clear. If you need any help, let me know.